Thanks for tuning in. My name's Kody Horvey. I'm with Up to Code. As typical Kody fashion, we're gonna beat up on the wood frame guys because we're ICF guys, and we're gonna compare and show you 5 reasons why ICF is way easier to obtain more airtight building, get the higher air exchange numbers than wood. It's so much simpler, easier. We don't have to worry about as much. So I'm going to show you that here right away. Reason number 1, we're going to start at the beginning. So we're going to start at the footing to wall connection. Now in this actual specific scenario, we're actually in an attached garage, but so that's why, like here, we've notched out the foam for other reasons. But the idea behind it is continuous insulation all the way down to the footing. Now this slab insulation literally just butts into the wall, but now you have continuous insulation. So you're, as in building envelope, this is a continuous insulation all the way around into your attic space, and it's very simple to do. Whereas conventional methods, you have your footing here, then they typically pour their slab on top of that, and then they build a frame of wood wall on top of the slab and then try to insulate that. So you have no continuous or continuity of the insulation. If you look at some of these photos, we actually take our vapor barrier and we acoustical it right to the ICF wall. And then we put the foam on top of that. And in the past, when our codes have actually changed, they're pretty strict, and now they've lightened up on it, but at one time it was 4 inches of insulation. So here we did 2 inches of insulation. We vapor barriered, we acousticaled all our joints, acousticaled it up the wall, and then we added another 2-inch layer on top of that. But like, yeah, it still just ties in with the wall system so simply, no extra fuss or extra labor required to get that continuous insulation. So reason number 2, we have no air loss at a floor connection. So we don't have a wood framed wall that stops with a wood wall or a wood floor sitting on top of that with another wall on top of that. That's a lot of area where air can infiltrate into the building, right? So here, our ICF wall just goes straight up all the way through. We have the continuous insulation inside and outside, where there's no hinge points, there's no weak points, and because it's ICF, the concrete in the core is what's giving us that air break. The foam does a lot too, but it's the concrete core that's doing most of it. Before we get into reason number 3, I want to share a bit of a story. A little background information is we recently just finished a full ICF house. We waited till the customer moved in. We knew the building was airtight, but we'd never actually done a formal blower door test or air exchange test. So we did it after the homeowner moved in, and we were blown away by the results. We got a 0.23 air exchange per hour. I have other videos where I explain what that is and what it means and how it compares to most wood frame guys. But that's a great number, especially when we weren't trying to. And that's the premise and the point of this video, is to show you that it's easier to obtain those good numbers. It's not a high number, it's just a high air tightness. It's actually a very low number. Most guys, wood frame guys, if they can reach a 1 air exchange, they're happy. But that's not to say that you can't achieve, there's guys that can achieve way better numbers than the 0.23. I'm not saying it's not capable with wood, it's just a lot easier with ICF. So that leads us into number 3. So we're going to compare a little bit. Probably the biggest reason is the fact that with ICF, I don't have to worry about any of the walls. So like we've already talked about, the footing to the wall or the slab to the wall connection, that's tight. We don't lose anything at the floors. Now on the walls, I don't have to worry about trades. That's probably the biggest thing. I don't, because a lot of trades are just used to working in a spec house or a production house. They don't know, okay, if I'm building a passive house and it's a wood frame, it's a whole different ball game. You can't do anything without proper direction or some sort of specific instructions. With an ICF, this foam doesn't matter. I got a little gap there. That does not let air in because I got the concrete core. So I don't have to worry about traits. I don't have to worry about, oh man, like I wasn't 100% sure, that guy didn't seem to give a crap. So he might have poked a little hole in the vapor barrier, or he might have ran his wire a little funny, or anything like that. An ICF doesn't matter. Like I can gouge the foam, doesn't affect my air tightness. If you did that to vapor barrier, if you even damaged it at all, you're subject to a huge air loss, right? And let me just show you why. If you look at this is actually a bonus room above a garage. So right away we have a 4-foot tall 3-ply girder. Then we wanted to get at least a little bit of R value, so we did an LVL 11¼ wall to match our ICF. We did a staggered stud. But if you look at the plywood and just look and pan around, you can see air gaps and all that in the plywood. So what the difference is ICF is not a wall cavity. This is a cavity. All these components, all these connections will allow air to come in. So then you have a vapor barrier on the inside, and that's what's stopping all the air and the air pressure from coming in and coming into the house and making it whatever, loosey-goosey, where it's just spilling and drafty and cold or whatever, right? We don't have to worry about those connections, right? We don't have to worry about, oh, okay, is my plate to my floor super tight? Did you put a special product in there? We don't have to worry about adding extra steps or being extra careful or specialty products. We don't have to worry about that. Our proof is in the pudding. We did an ICF house. We did our attention to detail. We did basically our vapor barrier on the ceiling. We did a very good job of, and we exceeded passive spec by almost 3. So let's get into more. So there's 5 reasons here. Let's keep going. So reason number 4 is our wall to our truss connection. So here this is just the way we like to do it. We have an LVL that's anchor bolted down to the concrete for multiple reasons. We're not getting into that. But here's some pictures of ones we've done in the past. And what we do is we acoustical sealant, and sometimes we'll do PL premium for adhesion, but we seal the connection between the concrete and the bottom of the LVL. So there's no air gap getting in through, there's no air squeaking in through this connection. If you didn't pay attention to that detail, that'd be a major, that'd be a bad location. That'd be a bad spot. We take care of that. Then from other photos, our vapor barrier that goes across the ceiling, we bring it down and then we just acoustical that joint again, and we even acoustical to the foam. Then when you put your drywall on, it just presses that tight, right? Nothing earth shattering though, right? Step 5, I mentioned before, you just take care of attention to all your ceiling vapor barrier. So if you have an exhaust fan or anything else, just pay attention to the details. But there's no earth shattering, multi-layers, oh, don't do this, don't do that. We just vapor barriered the ceiling, we drywalled it, we have an airtight house. And it's just so much simpler to achieve those numbers. Before I let you go, another little reference. This is a house that we did. We tested right after the 0.23 house that we tested. We went to a house that we had finished 4 years prior. Basically got permission from the customer, said, hey, can we do a blower door test here? Because we know we did a good job here, but we probably weren't as good. We obviously have learned some tricks in the past, but anyway, we did the test there. 0.42 air exchange per hour, 4 years prior. Didn't even know, didn't even try, and we still exceeded passive spec. So that's the proof's in the pudding.